first question would be, what happens if an earthquake cracks a storage in the half underground?
Okay, well, areas.
Possible.
Yes, it is possible, and in Japan there's a CO2 storage operation which was subjected to quite a strong earthquake 2 or 3 years ago. It didn't leak. We have in the North Sea, very close to Schleidner, it's one of the most earthquake-prone areas of northwest Europe, with earthquakes of 5, 6 magnitude on the Richter scale, and Schleidner's not leaked, and also the natural oil and gas fields that are in that area in the Viking Graben. They've held and retained hydrocarbons for many millions of years. So clearly earthquake risk is something you need to consider if you're storing CO2 in a region of the world which is earthquake prone. But of course there are many regions that aren't. But it doesn't necessarily mean you cannot store just because there are earthquakes there, but you do need to be aware that there is a risk, etc., and you need to understand whether an earthquake might compromise the storage site.
Yeah, and if there will be a leak, and if there carbon dioxide is leaking out of the ground, can it make any harm to people?
If it stays under the ground, the only people it could harm are people who are working underground, like miners. Yeah. If it comes to the surface, then yes, it can harm people, but only if they're not aware that the problem is there. As I showed in my talk, there are many areas in Europe where carbon dioxide, including Hungary, where carbon dioxide is naturally coming to surface through the geology, and people live with it, but they're aware that it's there, and therefore they don't do certain things in certain weather conditions, and they make sure that buildings are ventilated properly and things like that. Carbon dioxide disperses very readily in the air. If it didn't, we wouldn't be able to put carbon dioxide into the sky from our existing power plants. People live right by them, and there are thousands of kilotons of carbon dioxide going into the sky every day from one source. I mean, our largest power plant in Britain, which is Drax, is putting 2,000 tons of carbon dioxide into the sky right where people live. So, it disperses extremely readily. So carbon dioxide is a natural substance, and it easily disperses in air, and it's biodegradable, etc., etc. The problem comes when you're in confined spaces, and there's no ventilation, and that's when things can become dangerous for people. But we're aware of that. So if you know there is a risk of CO2 or the CO2 present in such a situation, then you take appropriate action.
So, although CCS is quite a new technology, do you consider it a safe one?
When you say safe, it means by what criteria do you mean safe? There will be storage operations that will go wrong. I can't guarantee that every storage operation is going to go perfectly correctly, no more than I can guarantee that you will get home tonight safely in your car. But beyond all reasonable doubt, if you as careful as you should be, then one can expect that you should get home safely. And it's the same with carbon dioxide storage, that if people keep to the rules of the game, then it should be safe. And if there is an unforeseen problem, then you have decisions to make whether to fix the problem or whether to stop storing the carbon dioxide at that site. You can always take the carbon dioxide back out again and pump it out if you had to. One of the things that people think is that CO2 would all come back out if it could leak out, but that's impossible. There is all sorts of mechanisms under the ground which would prevent that happening, even if you had an open pathway to the surface for all of the carbon dioxide to come back. But the fundamental factor in making the operation safe is choosing the correct geology. If you get that correct at the beginning, taking into account, like you've just mentioned, earthquake risk, etc., but lots of other, features about the geology. If you get all that correct, then that minimises the risk of something going on later on. So that first step of choosing the site is the most fundamental and crucial point, and that's what the directive, the European Commission's directive, majors on. Back to the issue, is it safe? Is it safe to emit it to the sky? And at the moment we have 100% leakage to the sky. And the unofficial results of looking at global CO2 concentrations in the atmosphere is we're around about 390 parts per million. And is that safe?
No, it doesn't sound.
It doesn't look safe to me. What we're doing at the moment is not safe. And that's putting it into the sky.
So why are we afraid of pumping it underground, or
I think
are we
it's
afraid at all?
I think some people are genuinely afraid, and it's a reasonable fear to have, particularly if you were living near where carbon dioxide might be put under the ground. You're right to be concerned, and you've a right to make sure that whoever's doing that is going to do it safely. But what I'm trying to say is that it is possible to demonstrate beyond all reasonable doubt that this can be done safely if, and this is it, the correct geology is chosen, and that's the most important step. What else? We already store gases underground. In Hungary, a lot of natural gas is stored underground. You have huge strategic reserves of natural gas stored underground in various parts of Hungary, and people accept that, and it's done safely. So why can't we do it with carbon dioxide, which will be generally put much deeper? And carbon dioxide can't explode, it can't burn, which methane can, but people accept putting methane underground.
Yeah.
So it all depends what you mean by safe, you see, what you're prepared to accept.
Okay, thank you. That's the message.
Yes.
Thanks for that.
Thank you.
Who am I? I'm basically a government scientist. I work for the Natural Environment Research Council in the UK, and a body of that is the British Geological Survey, the State Geological Survey for the UK, and the oldest one in the world. I also coordinate the European Research Network under the Framework 6 programme on geological storage of CO2. And we've just formed a legal entity, a not-for-profit one, the CO2 Geonet Association, which will take us beyond the Framework 6 funding. And we've applied for infrastructure funds under Framework 7 for some of the laboratories you're about to see in my talk. And at the British Geological Survey, I'm head of science policy for Europe. In other words, all the geological science aspects which can be informed policy in Europe, I'm responsible for, that come out of my organisation. So energy, climate change, pollution, natural resources, water, natural hazards, marine geology, earth observation, all in my remit. So if you want to talk to me about those other areas, I'm very happy as well. Our association, by the way, we want to have people joining, and we want strategic national organisations. We'd love some Eastern Europeans to join us, so if you're interested, come and talk to me. But the Framework 6 project has 13 research partners. We're recognised by the Carbon Sequestration Leadership Forum, and we're funded by Framework 6 grants and our own research organisations. That tells you a little bit about us, but a lot of science I'm going to go through. What are our impressions of